Hello everyone, welcome to this video again. Now in this video we are going to discuss, as I have said before, about the law of total probability. So let me first give out the heading. We are going to discuss about law of total probability. Okay, so the law of total probability is a theorem which actually connects you to the probabilities of different events which originate from a same branch. So let us consider an event E, which is a subset of the sample space omega, right? Now this is the event E, and we consider that the event E can be done in three different ways. Okay, the event T can also be done in three different ways. That's what I'm saying. So let us name those events as E1, E2, and E3. Okay. Now, in order to achieve this, in order to find the probability corresponding to E, what we need to do is we need to find out these transition probabilities. So, in order to find the probability of E, we need to find the transition probabilities of the sub events, obviously the sub events being E1, E2, E3. So the transition probabilities here would simply mean the probability of E1 given E, which is basically the inverse probability, right? So by law of total probability, which I'm going to state right now, and then I will generalize it for like n events. The probability of the event E is basically the probability of the event E1 into the probability of the event E divided by E1, or E conditioned upon E1, plus probability of the event E2 into probability of E divided by E2, plus probability of E3 into probability of E divided by E3. So this is the law of total probability, right? This states that the probability of the event E should be equal to firstly the probability of E1 multiplied by probability of E divided by E1, right? As you can see, a good way to remember this is write out every sub event and write the probability of the sub event and then condition it on the main event, such that if you just remove the probability signs, this fractions always should multiply to E. So E1 into E by E1, E2 into E by E2, E3 into E by E3, right? So that's how it works. That's how the law of total probability works. So for n events, let me draw the simple tree diagram here. For n events, the diagram should look something like this. So let's say this is our E. So this would be the sub branches. Okay, these are the sub branches, and the names would be, let's say this should be E1, this should be E2, this should be E3, and dot 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 dot, and this should be En, right? And then the law of total probability states that then the law of total probability states that probability of E should be equal to summation I equals to 1 to capital N, which is the number of sub events of the event E, probability of capital EI into probability of E conditioned upon EI, right? Well, of course, where EIs are the sub events and they belong to E, right? It is important to note that here the union of all the sub events is basically a proper subset of E, right? This has to be done because otherwise, if it is a superset of E, which cannot happen because otherwise then the event E would have a probability more than 1, which is not possible. That is why the union of these sub events must be a subset of E. Okay, so this completes the theory portion for law of total probability. Let us do a problem now. A problem here would be something like this. Problem 1. We shall do the second problem later, which would be a little bit more on the tougher side because it might require some algebraic manipulations, but we might do that in the next video. But for this video, let us consider on a problem 1 and understand how we can apply the basics. Given 3 bags of balls, they have the following composition. So we are given 3 bags of balls and I'm going to write down the composition in there which are given, right? So this is bag 1 and there are 2 kinds of balls, which is red and one is blue. Okay, bag 1 is here, bag 2 is here, and bag 3 is also here. So bag 1 has 5 red balls and 3 blue balls. Bag 2 has 2 red balls and 4 blue balls. Bag 3 has 5 red balls and 4 blue balls. Okay, so this is basically the distribution of the balls in the 3 bags. Now the question, what is the probability of picking a red ball randomly from a random bag? So basically here 2 things are random. One, the choice of a ball from a certain bag, and secondly the bag which you are choosing from is also a random bag, right? Because you are not really trying to choose it from bag 1, bag 2 or bag 3, but you are rather trying to randomize the bags and just put your hand in any one of them and then you get a ball, and then we are trying to find what is the probability that the ball that you picked is a red one, right? Okay, so I think the question is clear to everyone. Let us try to solve it. And this is one of the very basic applications of law of total probability. So we need to denote the events. Okay, so let B subscript I, where obviously 1 less than equals to I less than equals to 3, be the event that bag number I is chosen. Okay, now since bags are equally likely, bags are equally likely, we have probability of B1 equals to probability of B2 equals to probability of B3, right? And all of them should be equal to 1 by 3 because they're equally likely. So the choice of bags is equally likely. Now, what we next need to do is define events as follows. So, we are going to define the events as follows, which are like this. R should stand for picking a red ball, and B shall stand for picking a blue ball. So R and B, right? Now, as we have now already defined all our events, let me actually define this as, yeah, B is fine actually, because I think this is B subscript I, which is very much different from B, and we can distinguish it perfectly. So okay, now we know that a red ball can be picked in three different ways, right? A red ball can be picked from the bag 1, a red ball can be picked from bag 2, and a red ball can be picked from bag 3. Therefore, by law of total probability, by law of total probability, the probability of red should be something like this. The probability of red should be probability of B1 into probability of R by B1 plus probability of B2 into probability of R by B2 plus probability of B3 into probability of R by B3, right? Okay. So this should be the probability of R. Now what we need to find is this. We need to find the conditional probabilities. So we need to find probability of R by Bi for all the i's. For all I belongs to 1, 2, 3. So that is for all the bags. So we need to find the probability of getting a red ball given that a certain bag is selected, right? So let us go back to the list. For bag 1, there are 5 red balls and 3 blue balls, right? So in total, let me write down the total here, which shall help us in finding the probability easier. So this becomes 8, this becomes 6, and this becomes 9, right? So you can see the probability of choosing a red ball from bag 1 is 5 by 8. So we can write probability of R by B1 is equal to 5 by 8. Similarly, probability of R by B2 I think should be 2 by 6, which is 1 by 3. Let us check. It is 2 by 6, and the last one is 5 by 9, right? And probability of R by B3 should be 5 upon 9, right? Okay. And this completes actually all of our calculations. So lastly, therefore, probability of R should be, now as you know, all the probabilities of BIs are 1 by 3 as we have done already before, because the bags are basically random and equally likely. What we can differentiate in between them is something like this. We can take common 1 by 3 because all of this P of BIs are in multiplication form, and then we can add this, which is 5 by 8 plus 1 by 3 plus 5 by 9. Now let us simplify this, and I recommend it doing by hand and not using any calculator, because I do not think it requires much more time, but it's still feasible. So 72, it's 9545 is 24, and it's 40, I think. This gives you 45 and 40. It basically gives you 45, 40, 85, and 24 would be 109 by 72, and this would give you 109 divided by 216, which is our required answer, right? So this is the probability that we were looking for. As you can see, this kind of problems can be a little bit lengthy, little bit complex than before, as we have done in the series so far. But obviously, since the topics get harder and harder, the problems would become tougher and tougher. But we would try to find our way through it. As in this kind of problems in laws of total probability, we would try to actually find out all the details regarding the sub events, and we would try to draw something like this, so that we know exactly what to find and what else we need help with to find out the actual probability, right? Okay, so this completes this problem. In the next section, we shall do another problem of law of total probability and also Bayes theorem and its related applications. So thank you for watching, and please do download the British Math app. Please check it out. The link is in the description. It's a complete math tool for statistics and calculators, and the notes regarding this lectures are also in the app. Thank you.